So hi, I'm Dan. This is a. Oh, I'm sorry. This isn't my talk. This is Chris Withers' talk from 15 years ago called Python Package Management Sucks. And I found it on the Internet Archive. And it turns out that it was independent Zope consultant. Does anyone remember Zope? Yeah. But it goes through a lot of the, like, I wrote some code. I want to share some code. I want to use someone else's code. And it sucks. And he talks about the state of the art back in 2008. But I'm sorry, that's not my talk. That was an older one. This is my This is Armin Ronasher's blog post from 10 years ago saying Python packaging, hate everywhere. This is my talk. Why are there so many tools light at the end of the package tunnel? Python packaging is a quagmire and everything is terrible. And I'm sorry you're all in this room right now. But hopefully we can all make it through this and we can have some practical, at least visions of what utopia might await us if things actually happen. The way this talk works best is if I'm not just talking at you, if you're actually talking at me too. So choose your own adventure. If I say something stupid or I say something insightful and you want to know more, either case, yell at me. One quick plug before I dig in. I work for a startup called Suborbital. Our whole deal is that we try to make a plugin system off the shelf for SaaS applications. You've got a SaaS app, you want to run user code inside your app, we will do everything end to end. We'll give you an editor. We're powered by WebAssembly. We'll run the user code safely. I'm not saying this because you should be our customer. I'm saying this because we're trying to add Python support right now. And if you are interested in letting your users write Python functions to run inside your SaaS application, please talk to me because I need more insight into what we need to do right to make that work. So not a sales pitch, please help me find a fit. Sounds good. Anyway, this talk was supposed to be a really nice and easy thing. And then 15 days ago, Brett Cannon blogged about classifying Python virtual environment workflows. That blew up on Hacker News. He makes the point that there are a couple of reasons for the current situation. One is that Python predates Linux. And so I hadn't really thought about that. But yeah, we've had a lot of time to get things wrong or to not learn from other people because there weren't that many other people trying to do package management back then at a language level. Then Chris Warwick goes out and writes this blog post, How to Improve Python Packaging, or Why 14 Tools Are at Least 12 Too Many. And it starts out pretty good, and then it just descends into ad hominem, and it's huge. And then you get Brett Cannon, who's like the nicest Canadian ever, saying, just because it makes it a front page of HN doesn't mean it was written by someone who's deeply informed. And then he points to this thread as a better thing, which is, so you want to solve Python packaging, a practical guide. But Stargold goes and concludes, so you want to fix Python packaging? You fucking can't. Get lost. And then Prajan goes and writes another 6,000 words. And so all this happened in between me saying, yeah, sure, I can talk about packaging, and this week. And so what I'm going to try to do is try to explain what the hell's going on.
That was the Dan article?
Yeah, Linux Weekly News. Like, the rough conclusion that I can take away from all of this is, have you heard the saying that Python's the second best tool for any language? No, okay, someone. The idea that like it's not a specialized tool, it's never going to be the best tool for a given job, but it'll always be a reasonable choice for any job. And I thought that was pretty cool. And that means that Python has constituencies in systems administration, in web development, in data science, and machine learning. And the needs of those different communities are vastly, vastly different. And so trying to build one tool that suits everyone is probably impossible, to the point where there was a special interest group in the Python Software Foundation called Distutil-SIG that at one point threw up their hands and said, look, we're just going to try to define some standard interfaces because we are not going to make a choice for people because we can't make everyone happy. We give up. We'll get to that. The Python's the second best tool thing, though, I want to go back 23 years to June 23rd, 2000 to compiling C++ moderated on Usenet when someone says, quote, I forget who I heard it from, but I once heard C++ characterized as the second best language for almost everything. If you only want to use one language, C++ is was about your only choice. So in 23 years, things have gotten better. Now Python is the second best language instead of C++, but Python itself has a tooling problem.
Dan, do you know if that's zero-based or one indexing of second?
That's an exercise. I mean, like, is this even a total ordering, or are there? So let's talk. I'm going to make a recommendation, and then I'm going to stay here as long as Slice will let me. So if you want to leave at any point, just use Poetry. Poetry is a tool that will do everything for you. It's opinionated. It breaks in some ways, but it breaks in some ways that Pip eventually decided were the right ways to break, so it kind of adopted some of those. It's a well-designed tool. If you want to know how to do something, Poetry has a way to do it, and you're done. If you don't want to use Poetry, if you don't want to have one single tool to rule them all, setup tools is kind of the old stalwart. There are modern ways to use setup tools to package your Python dependencies or Python packages that are quite good. And then there's an upcoming project called Hatch that is looking really, really promising. So takeaway, if you want to package Python, look at these three things. Disclaimer, I don't know jack about Conda. Like the scientific computing people, the academic people all love Conda, no clue. I also have been infected by using the NixOS operating system. So like if you want to talk about functional programming and terrible ways to let Haskell run rampant inside everything, I'm here for that too. If you actually want to get work done, just use Poetry. What does packaging mean? Fundamentally, I want to let other people install my project. How do you do that? Python didn't have an answer for that for a long time because, again, remember, it predates Linux. It's an old thing. At one point in Python's history, a module was added to the standard library called distutils. And distutils had some really basic ways to add some metadata to packages. But it wasn't enough to be practical for actually distributing packages or running tests or doing other things you might want to do. So a gentleman by the name, I think it's like Philip Eby, wrote a project called Setup Tools. And inside Setup Tools was a tool called Easy Install. This was all under Peak, the Python Enterprise Application Kit that he worked on. And Easy Install was the predecessor to pip. You say Easy Install and you give it a zip file or a tarball or a URL, and it would go out, or eventually, as Patty mentioned, eventually a reference to a package name on the Python package index. It'd go out and find that source code, and it would somehow put it on your system in a way that your Python could import that module. The problem with Easy Install, one of the problems with Easy Install, is that it really only did what it said. There was no easy uninstall. Like you install and you were done, which in 2008 led Ian Bicking to create pip, which finally gave us uninstallation. So this kind of cycle of things where, like, when I'm packaging, I want to create one of two things. I either want an sdist or a bdist, a source distribution, which is just like, here's a copy of my repo, or a bdist, which is, here is something you can just unzip into your Python path and it will be there and ready to go. If anyone wants to talk more about that, I've got examples. I'm going to gloss over it otherwise. So we started with distutils. That didn't do enough. Philip made setup tools and Easy Install. Easy Install kind of didn't do enough. So Ian Bicking was like, I can do something that does a little more. I'll make pip. Then there was fighting because people didn't like decisions setup tools was making. And so Tarek Ziadeh forked setup tools into distribute, and some other folks worked on distutils too. And it was a whole thing. The individual that wrote setup tools initially didn't want other people to work on that project. And so hence all the forks, and there was no clear winner, and chaos reigned. Around 2013, I think it was when you have the PyPA era, the Python Packaging Authority, which is intended to be ironic. They had no actual authority until last year, where now they're actually funded by the PSF. But you had some folks convince the setup tools author to let other maintainers in, distribute merged in, distutils 2 went away, and suddenly we have a pip and a setup tools that are community maintained. and that have outside input and that can actually progress. Whereas before we were kind of locked in this era of like, there's a de facto standard, but there's no specification, and the person that's behind it isn't interested in collaborating on that. If you want to know more, the Python Packaging Authority has a whole history page, which is fantastic. Kind of breaks it down to the before 2013 and then on, calling out all the important PEPs and like what's been going on. But long story short, we went through this era of we don't know what we want, so everyone's building their own tool, to okay, we can collaborate as a community and build our own tool outside of the remit of core Python, because the core Python project had no interest in solving packaging. And not no interest, but have more or less thrown up its hands and said, look, there are too many people we need to serve. We can't come up with something that works for everyone. And then we ended up in our current chaos where like we've started, other people started looking at this and said, well, setup tools is cool, but it doesn't quite do, or pip is cool, it doesn't quite do everything I need. So I'm going to build another tool. If I'm building another tool, well, I also want to do this other thing and other thing and other thing. And you get this proliferation of tools that are very slightly different. Does anyone have questions or comments or frustrations that they would like to share before we move on?
I mean, can I just abstractly scream into the void?
Yes.
Period. Yeah, that was not fun. I came into Python land about 2 years after 18 still, but became the de facto for a while, and that was not a fun period to be trying to learn how to do pitching.
Right. And I mean, virtual environments weren't a thing for a long time. Those were also around 2008, 2009. And Python has this tension between it. In the early days, it was largely seen as just a better Perl. So it was being used for a lot of systems administration tasks. If you're running Linux, the Linux distro probably wrote some of its own core utilities in Python. So if you went and easy installed something, it would by default go into your system site packages. And that could conflict with or clash with or overwrite things that your operating system expected to be there. And just, we didn't have, like, we couldn't look at cargo. We couldn't look at NPM. We didn't, like, those didn't exist yet. Anyways, we've gotten to a point where the future, Python 3.12, distutils is leaving the standard library. Also, when you make a virtual environment, setup tools is no longer going to be included by default. The focus has shifted towards, instead of trying to provide solutions, to trying to provide consistent interfaces and standardized ways to provide metadata that arbitrary tools could then consume. But I want to step back to setup tools, because the closest thing the Python community has had to de facto standards have been pip for installation and setup tools for packaging. If you feel like you kind of know what setup tools is and does, could you raise your hand? Okay, good. Yeah. If you understand quantum mechanics, you don't. The idea behind setup tools is when I want to go and install something, given a blob of source code, I need to figure out like what files do I need, where do they need to go, what name should they be under. It'd be good to have metadata, like what version is this package, who wrote it. And setup tools had a way to do that. It was a de facto standard. It wasn't specified anywhere, but it was in this file called setup.py. And if we look at a project like Twisted, the async framework that existed before async.io went into the standard library, they used to distribute their software with a setup.py file that when you tried to install Twisted, it would say, okay, I'm going to go ahead and open this other file and just read it and exec it. And that other file is, again, just this massive, massive blob of code. It has some static data, metadata. So like this works in Python 2.7 and 3.7. Here's the URL, all that sort of stuff. And then it had these dependency specifiers like, oh, if you're doing development, you need PyFlakes. If you're doing, if you want the TLS variant, you'll need PyOpenSSL. And it would, in an executable format, generate the package's dependencies when asked to. You would run a Python file and it would spit out what it needed as dependencies and what its metadata was. And this is awful for tooling because it means that in order to know what I need to install something, I actually have to run arbitrary code on my machine. I can't just read the file. I can't just parse some JSON or some YAML and say, this is what I need. I have to actually go and execute Python. And that's kind of terrifying and terrible and frustrating because it one, poses a huge security risk. Two, makes it hard to do static analysis and automated tooling. Once setup tools have moved back into community maintainership, eventually, and this is kind of in the last 5 years, maybe even more recent, developed a way to specify all of the core things you might care about for a Python package in a static way, in a setup.cfg file. And so here, from Twisted 22.1, you can see like metadata, name Twisted, classifiers. It works on these versions of Python. Here are the dependencies, and it says, all right, if I need HTTP2, I'll need H2 in priority and whatever else. And this is a lot better because I can read this file using the like as a normal Python config file using packages in the standard library, and without running any code from Twisted, I can learn what I need to install it and to make it work. Much more recently, there has been a move to, this is PEP 621, to move all of this metadata into a file called pyproject.toml. And so again, Twisted, in its current version, has all of this information. Hey, if you're doing releases, Twisted uses town crier. If you're using TLS, you'll need PyOpenSSL. Again, all of this in a static file that can be read by tools and analyzed independently. The cool thing that it gives you, if you have the ability to do static analysis, is you can go into GitHub, or GitLab has a similar thing, and you can say, all right, well, if it works, PyProject.toml has no dependencies or is too large to display. I guess you can't see what the dependencies are there. Other projects will tell you. Let's look at, let's see, MVPy, GitHub. If you can, let's see, dependency graph in GitHub. So if you have metadata that GitHub is able to parse, they can tell you like, oh, okay, this application depends on docutils, on Markdown, and on simplenode.py. Markdown depends on coverage, import lib metadata, PyYAML, whatever else. And you can actually start to get a picture of what your programs really depend on. In this case, GitHub's pulling this out of setup.py. It's trying to read it and statically analyze it. It could be that if you actually tried to use this on your machine, it could generate something completely different for you because setup.py is executable. Anywho, the idea is that we're moving to a world where instead of having these ad hoc specified things that we're just taking out of this one project setup tools and de facto standardizing on, there has been a consistent effort to write PEPs to say, well, what do we actually need? What are the common things that a project might need? It needs a way to specify dependencies. It needs a way to say what versions of Python it works on. It needs to say who the author is. It needs to say what the homepage is. And once you have all of that in a neutral format, you can start building other tools to interact with it. And that's what you see with Twisted. Because Twisted doesn't use setup tools. It has this part at the top specified in another pep build system where it can say, okay, if I'm pip and I want to pip install Twisted from source, Twisted is actually using something called hatchling, which is a alternative to setup tools out of the Hatch project to define its metadata and to do its project management. And it has an entry point. The build backend is hatchling.build. And so pip or other tools that understand these new PEPs and these new standards for static declaration of metadata can go in there and say, okay, if I want to take Twisted and either take a source distribution and build a wheel out of it, or take a source distribution, install it on my system, do whatever, I'm first going to go and get these 3 other packages, and then I'm going to go and invoke hatchling.build. and I am guaranteed that that will spit out an artifact in the format that I would expect as if I were pulling it off of PyPI. Patty, have I said anything totally off there? Okay, great. So what has happened really in the last like 3-4 years is that we have broken with the history of setup tools. We have defined standard interfaces. We have made our tools generic. This is great because it means that you can choose a tool that fits your workflow. This is horrible because it means that you have to choose a tool for your workflow, and there is no single like de facto standard. In the same way that the Python ecosystem, NPM is the default. They have had similar battles over what the tools are: Yarn, Bower, PNPM. But NPM is the default tool. We don't have a default tool in Python. We have pip. But this kind of gets to the question of like, what do you actually want a tool to do? I can think of 4 things. I want to install packages. I want to manage dependencies. I want to create installable artifacts. And I want to publish to PyPI. Is there anything else you might want a tool to do?
So I've got one, and it's a bit of a question too. And
Yeah.
I agree, if we're talking about a Python package, that's it. But some of the stuff we referenced at the start, right? Like Thea's post about what a mess Python packaging is. Because Python packaging also includes like C code and C++ and Rust and Fortran and a ton of other languages that often speed up. Python's not in itself particularly. There are more performant languages perhaps to do an application in. So if you're trying to compile C code, is setup tools still the only show in town, or are there others?
No, there are others, and there are also quite a few language-specific tools. So it starts with an M. I'm forgetting the name, but like there's one that's recommended for Rust projects and whatever. The nice thing is now that we have these pluggable build system things that you can put at the top of your project.toml, you can then pick a build tool that makes sense for you, but it can be that package can still be installed by pip, just like any other package. One example of that is the markup safe library. So if I like pip install Flask, it goes and also pulls in markup safe. One of the problems with pip is that pip doesn't do enough, right? Like pip lets me go and install things, and I can go list what I have installed, but it doesn't actually tell me that I installed all these other things because I wanted Flask. It doesn't differentiate between something that I actually depend on directly and the things that my dependencies depend on. It also only records that I want Flask 2.2.2.2. It doesn't say anything about like, it doesn't have a lock file like you would expect to find in Rust or in Node that has like a cryptographic hash of, and this is what I think that version of Flask's files should be. Because right now, if I could give you any file that has malicious content, if it says it's Flask 2.2.2, pip would happily believe it satisfies this requirement. So there's some supply chain management, some like project management things. Like I go and uninstall Flask, and like, oh, I still have all these other libraries left in my environment. And this can cause issues in 2 ways. One, if I don't have a lock file, I can run into things breaking out from under me. Even if I specify exact versions of all my direct dependencies, if in between like me doing a CI run and doing a release, if one of my dependencies makes an incompatible change, like that next time you install it, you may just get like a bad version that doesn't work. It's not compatible anymore. So you want to be able to lock down everything, your direct and your indirect dependencies, and you also want to make sure that you're getting what you expect to get. The supply chain stuff has been a real issue with the TensorFlow library. Recently, they had a manifest of packages of dependencies for TensorFlow, and in there were some packages that were only expected to be available in their CI system or something like that for the nightly builds. Somebody was like, oh, I can just register that in PyPI. When somebody tries to install TensorFlow, it's going to go and grab that version in that file, and it'll just run it every time you install TensorFlow. Because there's no lock file, there's no cryptographic like guarantee that, hey, when I say I want Flask 2.2.2, this is exactly the sort of files I might want. Anyway, so I get markup safe in there. And markup safe if you go to its website on PyPI, and you go to download files, one, you can see like, here's the source distribution, and you can view the hashes. So I could record this and say, this is what I actually think this file should be. It also has a bunch of different built distributions that are all .whl. They're just zip files, but wheels, Python wheels, that are built for like, this is Windows 32 on CPython 3.9. This is macOS 10.9 on Intel. And what each of those have inside them would be, for example, in the macOS one, there is a speedups.c file in markup safe, because it's doing HTML escaping and markup parsing and whatever else. And you can do some of that a little faster if you have direct memory access that you get with C. But if I don't have a C compiler, I can't use that. So they provide these kind of pre-built ones where they say, all right, and here's a .so file, like a DLL, that's pre-built for Python 3.10 on macOS. And they kind of build out this huge combinatoric explosion of Python version operating system binary files. Capturing that, like how do you deal with these binary artifacts, is a huge part of why packaging is hard in Python. And that's really necessary. Like using Flask, you've got some C code somewhere in your dependency tree. If you're using almost any Python, somewhere in there you probably have a native module. And packaging those is hard because it's all very platform specific.
That jumps out at me that it doesn't have a PyProject.com or
Oh,
that'll be why in the
not in the wheel, but if we look at the TF, the actual source distribution, markup safe has a setup Py and a setup CFG, so that's still using the traditional setup tools stuff. But the idea is that like even if you didn't have the built stuff, you could feed this to pip and it would understand. If you've ever pip installed something, it's like, oh, I don't have wheel, so I'm falling back to legacy setup.py. What it's meaning is it's unzipping this and calling Python setup.py install instead of using the wheel tool, which like potentially could go and get these pre-built things or do some other like slightly nicer, more hygienic steps. Other questions, thoughts, comments, concerns? Yeah. So there's kind of this this thing of like, all right, so I want to install things, right? Under installing, like I might also care about like just like and hashing. Like, are you going to make sure that I'm installing the things I think I am installing? There's management. So like that's both of package sets. So like all of my dependencies, are you going to make sure all those stay in sync? But then also like, are you going to manage my virtual env? Are you going to manage my version of Python altogether? There is a proposal, PDM is a tool that I think it's like PEP 582 that's proposing, has not been accepted, but proposes, why don't we just have a folder called __ py packages __ and just implicitly always look in there inside the root of your project. And if we had that, maybe we wouldn't need virtual environments at all. That's an active discussion. We'll see where that goes. But there's a question of like, well, VMs are a pain. They're especially rough for newcomers to the language. I don't know. There's the, I want to build distributions. And that has both the side of like just specifying the metadata and then actually building the thing. There's a question of like, I want to publish it to PyPI. And you look at like, all right, well, pip, what does pip give me? I guess I can install things. It kind of will do hashing. You can force pip into hash checking. And there are things like pip tools, which will take a requirement, which will like compile a requirements file in with hashes and all that and make sure that that everything stays, like it works with pip just to make it easier to use the hash checking functions. But pip doesn't do anything to manage sets of files, really. I mean, you can pip freeze and you can give it a list of things, but that's doesn't want anything to do with your virtual envs, doesn't do anything with building, doesn't do anything with metadata, doesn't do anything with publishing. You look at something like, all right, I want to build something. Well, I need setup tools. And setup tools doesn't want anything to do with, I mean, yeah, it might do some installation stuff, but it certainly doesn't care about hashes. It'll help you define metadata. It'll shell out to, or it'll depend on other things like wheel as a module to help build things, or you can have other bits. But it doesn't help you get it to PyPI. For that, you need Twine. So Twine only really cares about pushing bits up to PyPI. Again, Patty, like this is you tell me if I'm wrong on any of this. This is literally your job. And so people started looking at this and saying, this is a really disjoint workflow. So Kenneth Wrights came along and wrote PipEnv. And that would handle installing packages, it'd do all the hashing, has a lock file. It synchronize entire sets so you can define like, here's my whole workspace. It would manage your virtual env for you. But again, nothing about like actually packaging or publishing things for other people to use. PipEnv's only really useful if you're building an application or managing a development environment for yourself. Okay, so Poetry comes along. And that's another kind of auteur saying like, I have a vision. I'm going to do this all my own way. I'm not going to participate with the other people in it. It's like, I know how to write a stat solver, and I'm going to fix Pip's terrible dependency resolution. And so, so Poetry does everything. It'll install things, it hashes things, it'll do like entire sets, it manages your virtual envs for you, it has a way to define metadata, it'll build your source distributions and your bdists, your wheels, it'll push it up to PyPI. Cool, it does everything. But it has a really strong opinion, so there are things that it just doesn't work with. It has strong opinions about SymVer, and like Python as an ecosystem is not SymVer complete universally. So there's some things that Poetry just can't deal with. But one of the initial motivations was the fact that for a long time, Pip was very naive in how if you said you want to install 10 packages and they each had 10 packages of their own that were dependencies, Pip would often either fail to find a compatible set of all of those versions that all said they would work together. Because you might say like, I depend on requests version 2 or 3, but not 4. And something else may say, well, I need 3 or 4. And so you need to make sure you select 3 and not 4 and not 2. Pip would sometimes either fail to find solutions when working ones existed, or it would just say YOLO and install things that explicitly conflict. And so Poetry came along and actually wrote a proper stat solver to find whether or not a mutually satisfiable dependency thing exists. And that was great. Pip then brought that solver back into core, so that differentiation's gone. But this was kind of the state of the art as of 2018-ish. And then there's been this explosion of, we've got PDM, we've got Flit, we've got Hatch.
You want audience participation then?
Sure.
So I'm questioning, given setup tools 2 ticks on their build and giving Poetry 2 ticks on their build. And I'm pretty sure you can't build your C code, right? The markup safe example had a C source file. I'm not sure that Poetry will compile that for you.
I believe Poetry will, because, or at least we're using Poetry. I don't work at Element anymore. We were using Poetry to build Rust. Flit does not allow you to do native extensions. I know that with certainty, but I believe Poetry does. But I could be wrong.
I think certainly in terms of like documentation and example, setup tools is still in the lead for building all these other languages. Setup tools is the closest thing. If you want something universal, like setup tools has been there from the beginning. The problem is you're going to trip over a lot of things that were written in 2007 that still depend on setup.py, that don't know that we can do this all declaratively in a setup.cfg or a setup or a pyproject.toml. And so kind of winnowing out what is the standard way versus what is the kind of old cruft that we're still bringing along, because it takes a long time for an ecosystem to change, is really hard. PDM does everything. Flit does everything except it won't build. It doesn't manage your VMs, and it won't build native C code or whatever else. But it can publish, it can install things, it can manage package sets. Hatch does everything. I think still is working on building native code,
but Hatch is new. Hatch seems to have a lot of momentum around it. The fact that Twisted, which is kind of famously conservative as a project, but has some really, really smart Python old hands in it, is using Hatch is compelling to me. But it does seem to have a lot of momentum.
Its publishing's a bit dodgy. Like it works with Python, but like trying it out on GitLab artifacts and stuff, it's
yeah. So again, there's no one tool to rule them all, but it does seem to be there is some interest in trying to build these broader one tool to rule them all workflow tools on the one end, and then up here this kind of decomposition of, well, I mean, there's another tool called Build, which like just works on building, and set of tools will use that. But you can also use Build to build things that are defined in Flit or defined with metadata in other ways. You can kind of choose your poison between, do you want the Unixy one tool for every step of this? In which case you can stay with setup tools and pip tools, or do you want Entwine, or do you want a single tool that kind of handles everything? And at that point, really Poetry and Hatch are the two that seem to be the best equipped. The pragmatic decision, the thing that made the decision when I was working on at Mozilla on the Mozilla Developer Network website, which was a Django app that moved from, we built our own called Hashin, but after we decided we didn't want to build our own, we switched to Poetry. And then at Element, when we were looking at some very large, very legacy Python code bases, we selected Poetry. The real deciding factor is everything kind of below this line is very new and has not had a lot of time to go out through the ecosystem, relatively new. Things that are up here have been around a little longer, and that leads to things like GitHub's Dependabot updates support only a few things. They support PEP 621, PyProject.toml dependency specifiers. They also support, let's see, where is the thing? Like supported package ecosystems. So you go into the GitHub docs and they're like, all right, you're using Python. We would prefer you use recommended formats or requirements.txt or a pipfile.lock, pipfile from pipenv. Or if you're using Poetry, the poetry.lock. We can try to read things from a pip file, your requirements.txt, setup py. We can try to read things from PyProject.toml, but really we want a lock file. They even have this little note saying, if you're using setup.py, we may not be able to parse and list every dependency of your project. And so when I look at that, what it tells me is like, I really want to stick with Poetry because Poetry.lock stuff is there, or something more like pip tools instead of like more kind of basic. Because that then gives me these automated alerts. Like whenever one of my dependencies has a vulnerability, I will get notified. I get this broader ecosystem benefit. I get the dependency graph. So when we have government customers saying like, we want to know the software bill of materials of everything going into your thing, we can point them to it. GitLab has similar supported languages and package managers. Python, here are your package managers, supported files. You know, we can look at setup.py. We can look at the requirements.txt from pip. We can do the pip file stuff, or we can do Poetry. So like I looked at that and it's like, there is some drama around Poetry transitioning from like the sole author has a vision, has started to include other outside contributors. There's been some back and forth. I don't think Poetry is the long-term solution for that reason, but it has been around long enough and solves enough problems, i.e. it has the lock file, so like you can actually get the same versions of the same files consistently, that it has been integrated into and supported in GitHub and GitLab and some of these other analysis tools. And that was really compelling for us. The future, though, is going to be with something like Hatch and using just PEP 621 style PyProject.toml dependencies. The big missing thing is that we don't have a way to specify locked dependencies yet. You can only say like, here's what I depend on, here's the version range I support, but you can't say like, and here is a complete rendered like set of all the exact dependencies and their hashes for reproducibility or consistency. There's not a standard way to do that yet. So you're still leaning on something like the poetry lock file or pipim's pipfile.lock. That's a mess, but it's been a mess for 15 years, and it's going to be a mess for probably another 5. But there is light at the end of the tunnel, because we are seeing, especially with the removal of distutils from the standard library, the removal of setup tools from virtual envs by default, this embracing of define the interface, let the tools figure out the right experience for their users, but in a way that's mutually compatible. Some of the current discourse is people saying, I really think pip should do more of this, and trying to figure out a way forward there. We'll see if it works or not, but that's where things are going. And it seems like Hatch has the most momentum right now. One thing I've learned in doing this at a couple of companies is that once you have your dependencies statically defined, it's not a big deal to move from tool to tool. It's not fun, but you can do it in a day. The important thing is getting there and getting a lock file and getting that reproducibility and getting that stuff kind of locked in a way that's not just a huge imperative, run this setup.py file, have it exec random code kind of mess, which is the way we did it for 20 years. Any questions, comments, despair?
There's a few other cool things to put in your diagram, like pip tools you mentioned, I think is really good and I've used across a few companies. Installer is one that, like, if you're into this, just do one thing, it takes a wheel and it puts it in your file system.
Yeah, pipx is also really nice as far as like just a fun thing to have that'll like go and create an isolated virtual environment just for one program and run it. Yeah, pip tools, it'll take it's 2 other files, pip compile and pip sync, so you can define like. So this is the tension, the lock file thing, application versus library. If you're building a library, you want other people to depend on your code. You want to support as broad of a dependency set as possible. You want to work with as many versions of requests, as many versions of Flask, as many versions of Django as you can. If you're building an application, you want to be damn sure that you know exactly everything going into it to make sure that things don't break from build to build, from day to day, just by the ecosystem moving out from under you. Pip tools kind of gives you a bit of the best of both worlds, where you can define your broad dependencies, but then call pip compile, and it'll actually like spit out, and here are their indirect dependencies, and here are the hashes of all those, and then pip sync will make a virtual env match that. So it's kind of nice because it's the one tool that does one job approach.
PipTools is the only one of those tools you must have been burnt by.
Patty says, yeah, PipTools is the only tool that he's never been burnt by, and that's does one thing, does it well. But you're up a creek in terms of like defining package metadata. If you want to share your application with something else, you're back to like, I got to choose setup tools or Flit or Hatch or Poetry. It doesn't do publishing, so you're either using Twine or using one of the other things. And that's the central tension in this whole debate, is what is right for a sysadmin is not right for a data analyst, is not right for an AI ML person, is not right for a web dev. And we finally realized that and created interfaces that are good enough for domain specific tools to do their thing, but play nicely with each other.
There are other communities, so Rust people like Cargo.
Yeah.
And is it the fact that Python feels a bit more like a university where we put apps and then people go off and academically debate app, and then someone builds their implementation of it, someone else builds their implementation of what actually you need to do?
So yeah, so the Rust community likes Cargo. Is it because Python's more academic and you write the PEP and you all go and noodle on it a bit? I was at Mozilla when we created Rust and Cargo, and Cargo was very intentional. A lot of the early Rust team had roots in the Ruby community, Steve Klabnik especially notably. And we looked at Ruby, and Ruby had kind of gone through a transition where Ruby existed for a decade, and then someone wrote Gem, which is kind of just pip. And then it took another 5 years before somebody wrote Bundler, which is kind of like a virtual env plus lock file, to make sure that exactly the versions of exactly the requirements you have are present and nothing else. And Bundler had the benefit of being able to look at a lot of the ecosystem and learn from it. The Ruby community, I think, never really expanded as broadly as Python did. Like, you weren't seeing Ruby used in data science to the same degree, or in like the machine learning or finance or whatever else. But when at Mozilla we were building Rust, we went out and got Yehuda Katz, who wrote Bundler, and said, all right, you've thought a lot about this. Come build a package manager for Rust so it's there on day one. And so Cargo was present from the get-go of Rust, which made it a lot easier for the community to standardize on it. There are still alternatives. I mean, like, there are a lot of projects that don't use Cargo to build their things, but by far and away the default is Cargo, and I think that's because it was there from the start. I don't know why other communities seem to be able to coalesce. I mentioned the JavaScript community. Like, NPM is the default, even though they have had a lot of reinvention, and that community is notorious for the libraries you use shifting and not having a long half-life. I don't know why the tooling has been more sticky there. The best guess I've seen, and going back to reading all those articles over the last 2 weeks, seems to go back to the breadth of the community that Python's trying to serve and the legacy it has. So you can't, I mean, it's Python code going back 20 years. So, all right, if it was built using setup tools, then like how do we keep that working now? We seem to care a little more about that in Python. Anything else, people?
So I think it's worth, like, there's been a lot of comment from a couple of speakers tonight that PEPs are a good thing, and PEPs lead to proliferation of competing tools.
Mm-hmm.
Once you standardize something, you enable people to implement it in different tools.
Yeah.
So I think it's disingenuous to highlight PEPs as being a good thing and then accept complaints when there's multiple implementations of a standard. So either we want standards, which means multiple tools, or we don't want, like, I kind of see a bit of a conflict there, and I think that's part of what came out in these blog posts. Yeah,
Pradyan's blog post is especially, I think, good on that point, where he talks about, like, now everyone has to make a decision. Now we have this proliferation. Yeah, the PEPs are great because they allow interoperability, but they force I think they also enable the proliferation. You're absolutely right. It didn't help that, like, 5 years ago, Guido was just like, I'm done. See you guys. I'm not going to make decisions anymore. But yeah, I'll post links to these trailheads, the conversations, things like that, to the meetup entry, if you want to go and read them yourselves. But otherwise, thank you, and I'm sorry. Please package your Python so other people can use it. Please do it in a declarative way. Poetry is a nice way to do that, but keep an eye on Hatch for, it seems like, where things are going.